Good morning, students. Today in this practical demonstration, we'll be doing with you the experiment number 4. This is again the titration of KMnO4 versus oxalic acid. The procedure will be same as was in the experiment 3, but the calculations are different. What is the procedure for this? You are provided with a solution C10. It is a solution containing 3.50 gram of potassium permanganate. Then C11 is a solution of oxalic acid which contains 6.50 gram per liter. Now rinse and fill the burette with C10 solution. What is to be done? We will take a burette, fill it with a C10 solution. Then pipette out 25 ml of oxalic acid solution in the conical flask. And to this, we will add 20 ml of sulfuric acid by measuring through a measuring cylinder. Then we will heat the conical flask up to 60 degrees C till the first bubble appears at the bottom of the flask. And once it is done, then we will add in a dropwise manner the KMnO4 solution till the persistent pink color is obtained. And whenever the persistent pink color is obtained, that will indicate the end point of the titration. This procedure is same as was done in the experiment number 3 and is written over here also. Rinse and fill the burette with a C10 solution of KMnO4. Pipette out 25 ml we will be pipetting out. 25 ml of the solution C11 of oxalic acid in the clean conical flask. To this add about 20 ml of dilute sulfuric acid C12 provided for the titration. Warm the content to about 60 degrees C till the bubble appear at the bottom of the flask. Now titrate the content in hot condition by dropping C10 solution from the burette till the permanent light pink color is obtained. Now you repeat this process twice or thrice, at least thrice, so as to obtain the two concordant reading. Concordant means the same reading. These two concordant reading will be indicating the end point of the titration. What will be the equation used? 2 mole of KMnO4 will react with 5 mole of oxalic acid in presence of H2SO4 to form potassium sulfate, manganese sulfate, water and carbon dioxide. So remember, what is the KMnO4? How many mole? 2 mole. Oxalic acid, 5 mole. Atomic masses are given. Ionic equation is also given. In this experiment number 4, you have to calculate the following. This calculation, the question which is being asked over here, are slightly different from those in the experiment number 3. Although the procedure of the titration is same. You have to calculate the molarity of oxalic acid solution, C11. Then molarity of KMnO4 solution, which is C10. Then concentration of potassium manganate solution in gram per liter. And the percentage purity of potassium manganate. Am I clear? Over there you find out the value of X for oxalic acid, which approximately come to be 2. Here we have to find out the percentage purity of a KMnO4. All the calculations for the molarity must be done up to 4 decimal places. This will be written as a note, as an instruction in the board paper. Calculate the molarity of the solution at least up to 4 decimal places. I hope the procedure is very clear, as you have done in the experiment number 3 also. Now again I will be demonstrating the same to you so that you may again understand how to obtain the titer value and how to go for the calculation. So we will be now demonstrating to you the titration for experiment number 4. So for the demonstration part, again I will let you get accustomed with the apparatus used. This is a clamp stand. This is a burner. This is a burette which is marked from 0 to 50. Then we have a pipette of a 25 ml capacity. This is a thermometer. You may see over here. Then a thermometer. Then we have a conical flask and a 3 beaker containing KMnO4 solution, which is C10. KMnO4 solution, which is C10, and oxalic acid solution, which is C11, and H2SO4 solution, which is C12. Am I clear? What is to be done? First of all, we will fill the burette with KMnO4 solution. So we will clamp. We have to clamp this, but before clamping this, since I have to demonstrate in the video lecture, so I'll be demonstrating it to you by holding it in the hand in the beginning. Then I will clamp so that you can easily observe. This is a burette marked from 0 to 50. Into this, I add KMnO4 solution. You may see student over here, and fill it to the 0 mark, which you can easily see as it has been etched on the burette. So here it is being filled up to this circular mark, and then I'll remove this clamp stent and clamp this burette in a clamp stent. Am I clear? Clamp this burette in the clamp stent. Now, I'll pipette out the oxalic acid solution into the conical flask. This is a conical flask, and this is C11, which is oxalic acid solution. So I'll pipette out up to the circular mark east on this. This is 25 ml capacity. Before this, you may shake it slightly so as to obtain the correct value. You may see over here, student, I have taken it up to the east mark, and 25 ml of this is being taken into the conical flask. Now, I will add 20 ml of sulfuric acid by measuring through a measuring cylinder. So, we will measure through a measuring cylinder and we will add 25 ml of this. 20 ml, sorry. 20 ml of this is being added into this. You may see over here, up to 20 ml I have filled up this dilute sulfuric acid. Now this dilute sulfuric acid will be added into the conical flask. Am I clear, student? Now I will heat this up to the temperature of 60 degrees C till the first bubble appears at the value over here. How will I heat this? I will put this over here. You may see over here. Now we will heat it up by first of all lighting up the burner. So you may see over here, burner is being lifted up. Now I'll put a wire gauge over it and the conical flask above it. You may see it. It is to be heated to a temperature of about 60 degrees C, and which can be easily seen by measuring the temperature with the thermometer. So I'll put it into this and observe that temperature rises to 60 degrees C till the first bubble appears at the bottom of the flask. Am I clear? So what I have done, I pipette out the oxalic acid solution into the conical flask. Then we have added the dilute sulfuric acid. Now we are heating it by putting it on the wire gauge over the tripod stand till the first bubble appear at the bottom of the flask, and this will appear at about the temperature of 60 degrees C. So when the temperature will rise up to about 60 degrees C, the first bubble will appear. You can see the level over here in the thermometer, and whenever you find out that this is heated up to approximately 60 degrees C, the first bubble will appear. You must keep a distance to see the first bubble appearing at the bottom of the flask. Am I getting clear, student? So what have we filled up in the burette? A KMnO4 solution. Then we are now heating the solution of oxalic acid and the H2SO4 till the first bubble appear at the bottom of the flask. Am I getting clear? Once it is being heated to 60 degrees C, then I will add drop by drop a KMnO4 solution till the persistent pink color appears. And as soon as the persistent pink color will appear, that will indicate the end point of the titration. Is it clear, student? So it is to be heated up to 60 degrees C. I will be demonstrating you only once, but you will be doing this titration at least thrice to obtain at least 2 concordant reading. And once the 2 concordant readings are obtained, that will indicate the end point of the titration. So you may see over here, first bubble need to appear at the bottom of the flask. It is only then we must start adding the KMnO4 solution into it. And then after obtaining the titer value, we will then do the calculations as asked in the paper. Remember, I have to find out the molarity of oxalic acid solution, molarity of KMnO4 solution, the concentration of KMnO4 solution, and the percentage purity of a KMnO4 solution. So 4 questions are to be solved. I think the first bubble have appeared. So now I will stop heating this. I will stop heating this and start the titration. How will I start the titration? Remove this from here. Put this conical flask below this. You may see over here. We will put the conical flask and then start adding KMnO4 solution in a drop-wise manner with a constant stirring till the permanent pink color appears at the bottom of the flask. So we will add this till the permanent pink color appear. I think the experimentation must be very, very clear, student. So this again KMnO4 solution is being added into the conical flask till the permanent pink color appears and appears at the bottom of the flask. This is slightly hot, so you must handle it with care. Continuously add KMnO4 solution with constant stirring. You must obtain at least 3 concordant reading or at least 2 concordant reading to obtain the titer value of the titration. And then from that titer value, we will conduct the experimentation further. Am I getting clear, student? So you may see over here that till the persistent pink color is obtained, that will indicate the end point of the titration. You may see over here it is still decolorizing. So few more drops of a KMnO4 solution is to be added into this till the persistent light pink color is obtained. We will be obtaining the persistent light pink color. Whenever you think it is nearer to the light pink color, slow down the speed of addition of a KMnO4 solution so that you can clearly observe the value and this is being obtained. Now you may see, student, over here, this only require hardly a drop or 2 for obtaining the KMnO4 pink, for obtaining the persistent pink color. Now this over here is almost there. Yes, student, I hope you must have been able to understand this. You may see over here a persistent light pink color is obtained, which is now no more getting decolorized. So this is the end point of the titration. And if I see this value, it is coming to be about 24.1. So what is the end point of the titration? Which is 24.1. Now the calculation is to be done. How do we go with the calculation of a titration? First of all, the observation table is to be made. This is serial number. This is 1, 2, 3, at least 3 times the reading is to be taken. Initial value of oxalic acid taken is, this is the size of a pipette, 25 ml. Whatever the size will be given to you, that will be told to you when you do the practical in the laboratory. Initial value of burette is 0. What is the titer value coming over here? Here it comes to be 24. Here 24. Here it comes to be 24.1. This is 24.1. Now, what will be the final value? 24 minus 0, 24. This is 24.1 and 24.1. You may see over here, these two readings are the common reading. So, what will be the titer value? It will be 24.1 ml. So, titer value of this titration is 24.1 ml. What will be the capacity of the pipette used? 25 ml used. Titer value 24.1 ml. Now, we have to do the calculations for the 4 questions which is being asked in the question paper. What was the first one? We have to calculate the molarity of hydrated oxalic acid solution. This is C11 solution and this will be represented as M1. So, molarity of oxalic acid solution will be strength or the weight in gram per liter of oxalic acid upon molecular weight. What is the strength given? It is given as 6.50. So, divided by the molecular weight of oxalic acid, which is 126, it will be equal to 0.05158. Up to at least 4 decimal place it must be calculated. So, first calculation is clear. This will be the molarity of oxalic acid solution. Second is we have to find out the molarity of KMnO4 solution, which is a C10A solution over here. So, molarity of KMnO4 solution, which will be a C10 solution. This will be M1V1 upon M2V2. M1V1 will be for oxalic acid, M2V2 will be for KMnO4 solution. This will be equal to N1 upon N2. What is molarity of oxalic acid? 0.05158. Volume of oxalic acid solution used is 25 ml. Am I clear? How do I know? Because the size of the pipette was 25 ml. Then M2 into 24.1 ml. What is 24.1 ml over here? It is the titer value, that is the volume of KMnO4 solution used. And this will be equal to 5 upon 2. So, if we solve this N2, this will come out to be equal to 0.02140 molar. So, what is the value coming over here? The value over here will be equal to 0.02140 molar. This is how we find out the molarity of a KMnO4 solution. Then the concentration of a KMnO4 solution. This will be concentration or the strength of KMnO4 solution will be molarity multiplied by molecular weight. Just see the question, what we have to find out? The concentration of a KMnO4 solution. So, this will be molarity multiplied by molecular weight. So, 0.02140 into 158, it will come out to be equal to 3.3812 gram per liter. Now, fourth is we have to find out the percentage purity. What is the amount of substance obtained over here? 3.3812. What was the given mass? 3.50. So, 3.812 divided by 3.50 into 100. So, what is the percentage purity coming over here? It will be equal to 96.60. I think the calculations must be very clear to you, students. So, this was experiment number 4, in which we calculated the molarity of oxalic acid, molarity of KMnO4 solution, then the concentration of KMnO4 solution and the percentage purity of a KMnO4 solution. So, students, now we have demonstrated to you the 4 experiments that were the titration of KMnO4 versus ferrous ammonium sulfate. 2 types of calculation were done in that. Then the KMnO4 versus oxalic acid, 2 types of titrations were done in that. You please observe these videos very, very carefully. Whenever you come to the lab, we will be providing you the solution of KMnO4 and oxalic acid and ferrous ammonium sulfate. You will be doing the 2 titrations and then the calculations will be for the similar kind of questions you have to do. And 4 experiments will be done in this manner in the lab. So, hopefully we will be meeting soon in the laboratory to conduct the experiment. I expect you to see the videos very carefully and understand how to conduct the experiment. We will meet soon. Till then, thank you.